Hello everyone. This is, I'm sure, your long-awaited video that I said I would make and haven't made yet. So it's now Thursday morning on holiday break, and I wanted to give you a brief overview of five different kinds of chemical reactions. There'll be five basic reaction types. Of course, there are myriad other options for chemical reactions, but these are the five basic ones that we're going to focus on. Okay, the first one is synthesis. So what does a synthesis reaction mean? Synthesis, of course, means to make something. Like in music, a synthesizer is a, oops, cancel that. A synthesizer is something that creates a sound or something. A synthesis is a creation. To synthesize means to bring together. So the basic format would be A plus B yields AB. So some substance A plus some substance B would make a new substance AB. Notice how many there are. There's a substance here, there's a substance here, but on the right side of the arrow, on the product side, there's only one product. So synthesizing two or more things come together to make one. All right. The second type of reaction is decomposition. A decomposition is the opposite of synthesis. So if you have reaction type AB, or substance AB, I meant to say, then you can end up with substance A plus substance B. Notice that we have one thing here turning into two or more things. So one substance turns into two or more substances. Second reaction type. Okay, so an example. So if I have H2 plus O2, which is the equation for the formation of water. You have to put a 2 here and a 2 here to make sure that everything's even. That would be which kind of reaction? Would that be synthesis or decomposition? All right. But the other way around, if the H2O comes apart to make H2, whoops. Here, we'll make it neater. And O2, now I've got a decomposition because I've got one thing here turning into two things. So those are the first two of the five reaction types. Okay, the third type I'm going to show you is one we've done before. These are called double replacement. All right, in double replacement, you have maybe AX plus BY. Okay, you've got a cation, anion, cation, anion. They change partners. So the A would go where the B was. So now you have AY. So the A comes over here to where the B is. The B goes where the A was. So you would have BX. Now, since this is positive and negative and positive and negative, over on this side, positive, negative, positive, and negative. You would not put two positives together, so AB would not go together, and you also wouldn't put two negatives together, so XY would not be able to go together. Okay, it's called double replacement because the A replaced the B, and the B replaced the A. All right, and I'll give you an example of that in a minute. Okay, the fourth one is called a single replacement. Now we've done these as well, but we haven't spent as much time on the single as we did the double. Okay, so an example would be from the halogen lab where we had bromine plus sodium iodide. Oops. I wasn't going to give you an example before I gave you the general format, so let me change back to the general format. Okay, so the general format would be A plus XY yields AY plus X. Okay, another general format might be Z plus XY yields XZ plus Y. All right, notice that in the first one, A replaced X. Only one thing got replaced. That was the X. So that's called a single replacement. In the second case, Z replaced the Y. Well, still only one thing got replaced. Single replacement. Now, what is a little bit confusing, potentially, about single replacements is that in a single replacement, if element A is a cation, would form a cation. What kind of things form cations, by the way? Metals or nonmetals? Oops, ion. Okay, so if this element forms a cation, it'll replace the cation. So this guy here would come in and replace X. Okay, so metals form cations. So if this was a metal, or hydrogen, but usually just a metal, the metal would replace the first part of the compound. But if this first element would form an anion, so if Z would form an anion, a negative ion, what kind of elements form negative ions? That'd be just nonmetals, right? Okay, so if the negative ion, the nonmetal, is reacting with a compound, the nonmetal ion, the anion, would replace Y. All right, I have to open up another sheet here. Let me see if I can find quickly another sheet to open. All right, we'll just continue on this sheet. Get this up here where you can see it. Double replacement, single replacement, right there. Okay. Okay, so here's a couple of examples of these reactions. Tell me which one this would be. So if I had, say, zinc. So I'm over here with zinc plus HCl. It can turn into zinc chloride plus hydrogen. Okay, this zinc would form, it's a metal, so it would form a cation. So based on what we said up here, those things that form a cation would replace the cation. So the zinc would replace the positive part of this compound, so it would come over here and replace the H. And see how that happened? The zinc went where the H was, now I got zinc with chlorine, and then hydrogen's by itself. Now, we've talked about this briefly, but just to remind you, there exists a group of elements when they're by themselves. They always occur in pairs, and that's why I put a H2 down here. So it's we call them the Brinkelhoffs. It's easy to remember that way. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine always occur in pairs when they're by themselves. Okay, so what kind of reaction? Single replacement. Another example. Okay, the bromine here, that would form an anion, so it would replace the anion part of the compound. So you'd have NaBr, and then iodine to be kicked out. And once again, I put the two subscripts down here and here because bromine and iodine are both part of the Brinkelhoff family, or Brinkelhoff group of elements. It's not really technically a family, but we call them the Brinkelhoffs because they kind of act like a family. But by the strictest definition of family in chemistry, they aren't, because they're not all in the same column. All right, so those are two examples of single replacement. We've done several double replacements, so just an example, silver, suppose you have silver nitrate and potassium sulfate. They would trade partners. Remember, you put the positives with the negative from the other group, so you'd have silver with sulfate and potassium with nitrate. You will notice that I carried over this 4 right here and this 3 right here, because the 4 and the 3 are both part of the polyatomic ions, sulfate and nitrate. I did not carry over the 2 that was part of the potassium, because potassium is not a polyatomic ion. Okay, after we get to this point, we have to write the chemical formulas. So that's 1 and that was -2, so it's Ag2SO4. And then this is +1, that's -1, so that formula is already okay. Now we need to balance the equation from side to side. So we got 2 silver, so we got 1 silver, so we put a 2 over here, which also gives us then 2 nitrates as a side effect. Remember, this 2 stops affecting things when you get to the plus sign, but it doubles everything here. So 2 NO3s. Over here I've only got 1 NO3, so I had to put a 2 in front, which then multiplies my K. So now I have 2 Ks, because 2 times 1 is 2. There's only 1 K in the formula, times 2. But on this side, there are already 2 Ks, so the equation now is balanced. Okay, so those are 3 examples. So what was this one again? Single replacement, double replacement. This one's double because silver replaced the K replaces silver. And now there's one other type of reaction. The 5th kind of reaction is a pretty simple one. So reaction type number 5 is called combustion. Combustion involves burning a hydrocarbon. I'm going to use methane as an example because right now I can hear my furnace running, which reminds me that that's what I'm burning to heat my house. So I've got CH4 plus oxygen. So combustion means to burn. What's burning mean? Combine, burn to create Some of you have heard of global warming and increased level of carbon dioxide. Carbon dioxide is the famous greenhouse gas that causes our atmosphere to retain heat. Anytime we burn a hydrocarbon, which is when we heat our houses, or burn gasoline, we create CO2. That's why people are looking for alternatives, ways to manage energy without the creation of CO2. Okay, so this makes carbon dioxide and water. They always make the same thing, carbon dioxide and water. Now, of course, it is possible to have incomplete combustion, and we'll talk more about that when we do a lab on this, but you can end up with just plain carbon or carbon monoxide instead of carbon dioxide, but we are going to assume complete combustion. So I have 4 H's. I have 2 H's. To balance it, I have to put a 2 here, which gives me 4 H's, but that also gives me 2 O's. If you look over here, though, but I have 2 O's here. So I've got 2 O's on here plus 2 O's there. So I really have 4 O's on the right side of this, 4 oxygen atoms on the right side of the equation. So on the left side of the arrow, there are only 2, so I had to put a 2 in front of that. All right, so those are our 5 types of reactions. In a separate video, I'm going to make a movie just giving more examples of the different types of reactions and some of the specialties that we need to consider, some specialized types of reactions within synthesis and decomposition. So that's the end of this one, and I'll try and get the next one created in the next day or so.